Hello again, we are in chapter 12, and here we are going to look into the very interesting concept of counterfactuals, which help us reveal certain situations that are the cause or seemingly the cause of the result, and perhaps how we can change the result by changing certain factors that are taken into account. So the example that we use here is called German credit data. This is a very famous, highly documented data set that shows decisions of giving somebody a credit or not, basically giving them a loan or not, which is what you see here in this row. So this is an Excel view of the dataset, and what we have is a smaller version of the same dataset. It doesn't have all the columns and doesn't have exactly all the values, but it is also a common version of it. And you have the actual CSV file in here. You can also view it here. It looks less meaningful. So what we see here is an Excel spreadsheet where the dataset is being shown, and the columns are the different features, you can call it, and the last column is the results. So these features are all kind of factors that are part of the decision if that person gets a loan or not. So it is well documented. It's also, the book has the exact definitions, but generally speaking, checking account status is denoted by a certain number. The duration of the loan and the amount of the loan are here. The credit history is also shown with some status number. The status of the savings account, the employment duration, etc., etc. And at some point, somebody sat and decided that based on this information, this person, for example, this particular person is a credit risk, so did not get a loan. And we are trying to look at the question is, can we change? What needs to be done to change the decision? If we can figure out certain changes, or sometimes you want to ask what are the minimal changes? What does the person need to change to be able to get a loan, or maybe to be able to get a better loan? We can ask a lot of what if questions. What if we wanted to do this? What if we can change this? And genetic algorithms, interestingly, are very good at finding those combinations that will change the result the way we want it. So we're going to look at a particular applicant for starters, which is this row, which is actually the 25th row here. But if you start from 0, and if you start from this row, so this person was denied, and as you can see in the last column, and there are different pieces of information that show us that situation of the person. We are looking at this program that's called the credit risk data. And what we see here is that the first thing we do is we take a model, a random forest model, actually, and we train it on this data. So the model sort of learns to imitate the decisions that were done by humans or by whatever was making the decisions. And once this model is a good enough imitator, we start to use that and try to predict what happens if we change this or change that. Also, in certain models, we can see the importance of different features. So this program will do that. It will give us the importance of features. And then we will take this applicant, which is here called applicant number 25, and then we will try to change 4 values, and we chose only 4 values that we want to change here in our programs, and we can see it here. We only want to look at changing the amount of the loan, the duration of the loan, the status of the checking account, and the status of the savings account. One reason that we concentrate on this is because these are things that we actually can change, or are easier to change perhaps than others. For example, employment duration, other debtors, etc. may be things that are harder to change, or we don't really want to deal with it. And we want to see if these four features alone we can get what we want, and how much we will have to change them if we want to do that. So that same program changes those four numbers accordingly, because we already tried it manually and we know actually. So once you change the original values to these, you will see that according to the model, the person, the applicant, will get the loan. So let's run it quickly. And what we see here is that before the modification, these were all the values, and the credit risk is 1, which is what we saw in the spreadsheet. And after modifying those four values, we got to now the credit risk is gone, and the person is going to get the loan. So now we are going to open this program that runs a genetic algorithm, and the purpose of this program is to find the minimal change that we can do to those four values, or part of those four values, and change the decision to loan approved, basically, from loan not approved. So here we have the four values. We define certain ranges. So for example, the amount we want it to be, we allow it to be between 100 and 5,000, etc. And what we're trying to optimize here is the cost. And the cost says that first it has to be a positive outcome. We want it to be approved, so we put a penalty if it doesn't. And then we want the difference from the original values, whatever they were, to be the minimal difference. And this gives us a sum of the differences between the amount that was changed versus the original amount. And we're going to run that and see what is the minimal change that will hopefully change the decision. So what we see here is the original set of values. And what we see here is that if the amount is 1370, which is very, very close to the original one, original was 1374. If the duration is 16, checking is 1 and saving is 1, which actually is the same as before, then it's not a risk. And actually what we can conclude from that, we can try instead of this to put the original amount that was 1374, and it still works. So changing the duration to 16 from the duration that was 6 will get the loan approved. So that gave us a way to get approved for a loan. Let's play a little bit with it some more, and let's say, what if we want maybe not to go up to 16, we only want to go to 12 months at max. So we can replace this. So now let's say that we are okay with between $1,000 and $2,000, but we want the loan duration be no more than 12 months. And let's see if this is possible, if we can find a combination that will do that. So here we found a combination. If you're going down to 1249 and 12 months, then we don't have to change anything else, and we get approved. If we look at the book, we will find some other situation there that we try to do all kind of other interesting manipulations and find all kind of other conditions. What if we want a smaller amount of months? What if we change the status of the account, etc.? And we find some interesting findings. And here we are going to just show one more case, that is the following. We are now going to look at another case, and that would be another applicant that we see here. We call it applicant 68, because line 70 is actually a 68 index. And this applicant actually was not considered a risk, meaning he was approved, or they were approved, and we can see the information of the applicant here, and we see that these are the important things for us, and the amount was 8019, etc. We want to see what is the maximum that we could get without changing anything else. What if everything stays the same, but the amount is allowed to go to, let's say, 50,000, and we are going to maximize that amount without breaking the approval. So this is what the second program here does. And if we run it, we find that if we go up to the amount of 14,165 without changing, while all these remain the same as before, then we still get approved. That is the largest number we could find. So that is one way to maximize, to figure out how you can maximize your current situation. In the book, you'll find some other interesting cases that we're trying. Also some cases that show that there is possibly a problem with the model or problem with the data. So you're welcome to explore that and follow the examples in the book, and try your own cases. There is plenty of information here, all kind of applicants. You can just choose one and start playing with it. So this is where we conclude with chapter 12, with causality, counterfactuals, and the genetic algorithms manipulating it. And I will see you in the next video, chapter 13.